we're in this worksheet, we are going to be finding the inverse and doing calculating simultaneous equations with matrices, but we're going to use it without the calculator. Why we have to do it without the calculator? Because they ask you to show how it's worked out. So the answer doesn't give you the mark, the working out gives you the marks. So just to make it clear, the inverse matrix is, you can call it the inverse, or a matrix to the power of -1 is also the inverse. Okay, so just remember that. So here, the first one, we're asked to find the inverse of this matrix here. Okay, so the first step is to find the determinant. Now, the determinant is when we do this spot times that spot, so 2 times 4, then we minus, and it's going to be this spot times that spot. So that's just the rule that you do, okay? So if we did that, that would be 8 minus 12, so it ends up being -4. So that's the first step of finding the inverse matrix. Now the second step is we write 1 over the determinant, which we just found, and what we're going to do is the matrix, the number in that spot and the number in that spot are going to get swapped. So that's what we have to do, that's what the rule is. And then the numbers in these spots, those two spots, become negative. So that's my abbreviation for negative. Okay, so that's what we need to do. So if we were looking at our example, we would say 1 over -4, because that was my determinant. And I'm going to swap those two spots. So 4 goes up here, 2 goes down here. And then I've got negative, the 3 becomes negative, and the 4 becomes negative. If the number was already negative, you'd make it positive. Okay, so now we're up to this bit. When you have a number outside a matrix, so it's a number, not another matrix, a number, that's what we call scalar. So really what we're going to do with scalar multiplication means we're going to times everything inside that matrix by that fraction on the outside. So when you have a fraction on like that, what it actually means is you divide by every number inside by that number that's on the bottom. So it'd be 4 divided by -4. It'll be -3 divided by -4. -4 divided by -4, and 2 divided by -4. Okay? So all the way up to this point would be what you need to be able to show. Okay? All the other things like simplifying the fraction or things like that, that's okay if you can't do that. You can let the calculator, but you need to show the rest. The calculator's not going to write out this way, and we need to. So we can simplify. So if we have 4 over 4, what does that end? That's 1, isn't it? And because we have a negative, it becomes -1. If I have two negatives, so negative divided by negative, what does that become? A positive. Good. So that one becomes positive. This bottom one becomes +1. And if I've got 2/4, what do I have? I have a half, don't I? So we could say this one's -1/2 because the bottom number. Okay, so I have just found the inverse there. That's the inverse matrix. Okay, so let's go with this next one. So we've got to find the inverse. So remember the inverse, just to remind you, that's when we raise it to the power of -1 on the calculator, but we've got to manually do it. So first I've got to find the determinant. So the determinant's going to be 5 times 3 minus 7 times 2. So we end up with 15 minus 14, so we end up with 1. Okay, then to find the inverse, we've got to do 1 over the determinant. So for me, it's 1 this time. Then we've got to swap these two. So 3 comes up here, 5 goes down there, and we make the other two negative. Okay, so whatever the determinant is, so it's actually this number, that's what we're going to pop at the bottom. So it would be 3 over 1, negative 7 over 1. But what is anything over 1? It's just itself, isn't it? So we could go straight and leave that answer like, sorry. And there's our answer. Okay, so let's do this one. So the determinant of this one would equal 1 times 4 minus 1 times 3. So this one ends up being 1 again. So we've got 1 over 1. We're going to swap these two numbers round and make these ones negative. Okay, so we can go straight. We now know that anything over 1 is 1. So we'll just go straight to the answer. Okay, so for the following simultaneous equation, it says first show the equation in matrix form. So in the green here, I'm going to show this matrix this is in matrix form. So this is the first thing I'm going to do. So when we do it in matrix form, the first matrix has all the numbers that are in front of the letters. If there's no number there, it's assumed a 1. So we've got 1, 1, 3, and 4. Okay, then we do times, and then we have a matrix that has whatever our unknowns are. So our unknowns here are x and y. So x and y get put into that one. Then we say it equals, and then we write what the equations were equaling. So the first equation was 3, and the next one was 2. So that's how we set up. So if they say show these equations in matrix form, that's what you have to do. Then they want you to solve the set of equations, and they want us to do it manually. Okay, so if we're going to solve the equations, what we're actually finding out is this is what we want to know. We want to know that 2 by 1 matrix. That will tell me what x and y is. So the way we solve it is we get that first one, and you've been doing it on your calculator, and we raise it to -1, and we times it by that end one. So what did we just see before? If something's times to the power of -1, what is that called? Inverse. Good. So if I have to do this without my calculator, that means the next step is first find the inverse. Yeah? So I'm going to find that inverse matrix first. Yeah? That's the first thing I'm going to do. Alright, so the inverse of this one. So 1, 1, 3, 4. So the first I would do is find the determinant. So it's 1 times 4 minus 1 times 3. So this one was easy. It's a 1. Yeah? So then when I'm finding the inverse, it'd be 1 over the determinant. We're going to swap those two round and make the other two negative. Okay? Then that would simplify, wouldn't it? Because it's over 1. 4, -1, -3, and 1. Alright, so I've found the inverse. So now, I've run out of room, I'm going up here. So if I'm going to continue on with my solving, so what I've actually got is I've now got the inverse. I don't need to put in the calc, I've found that already. And I'm going to times it by the 3 and the 2. Okay, so now what we're going to do, we're going to do manual multiplication. Yeah? So if we have a little look, this is a 2 by 2 and this is a 2 by 1. Is it defined? Yes. Yeah, because these two numbers are equal. And what will my answer be? Good, it'll be a 2 by 1, won't it? Those outdoor numbers. So we're going to end up with a matrix that has 2 rows. There'll be an answer there and an answer there and 1 column. Alright, so we're going to do the run and dive. So I'm in row 1, go run and dive. So what's actually happening there? we've got 4 times 3 plus negative 1 times 2. So the first row with the first column. And then if I do this second row with the column, that's going to go in the bottom row. Second row, negative 3 times 3 plus 1 times 2. So then you can actually do those numbers. That ends up being 12 plus negative 2 and negative 9 plus 2. So what's 12 plus negative 2? 10. And negative 9 plus 2 is negative 7. Okay? So what you've found is that. So what does x equal? Therefore, you could tell me x equals 10 and y equals 7. Okay, so we're going to solve this, and the first set, I'm just going to put it in matrix form first because they have asked us to do that in the question. So matrix form for this one would be 4, 3, 1 and 2. Then I times it by x and y, and I said it equals 10 and 2. Okay, if I was going to solve it, and I had to write how to solve, what I would be doing is I would be finding the inverse of this first one. So I could write it like that, and I'm going to times it by that. So I need to find the inverse first. So what I'm going to do is first find the determinant of that matrix. So it's 4 times 2 minus 3 times 1. So that is 8 minus 3, which is 5. So then when we do the inverse, it's 1 over 5. We're going to swap these numbers round and we make the other ones negative. Okay, now what I said before, because this number on the bottom, that's the determinant, when you multiply it out with the numbers in the matrix, it'll just become this. It'll just become 2 over 5, negative 3 over 5, negative 1 over 5, and 4 over 5. Okay? So that's now the inverse. So if I'm continuing on with solving, I now know what the inverse is fully. So 2 over 5, negative 3 over 5, 1 over 5, and 4 over 5. And what I'm going to do is now manually times it with 10 and 2. Okay, so you still need to show that next bit. So we know it's going to be a 2 by 1. So that means there's going to be an answer here and an answer here. So we still need to show this step. So I'm in the first row, first column. So that will be, now you don't have to work it out, just write it out. It'll be 2/5 times 10 plus negative 3 on 5 times 2. Don't worry about working it out. You can just leave it as long as you've written that bit. That's showing that you know what's happening. And then the next bit would be this row by that column. So it'll be negative 1 over 5 times 10 plus 4 over 5 times 2. Okay, what I would suggest you do, because you will have your calculator, is go pop it in your calculator and get what the answer should be. Okay, so what we did is we've typed it into the calc and we got the answer. Okay, and then there's it. So we know x equals 2.8 or y equals negative 0.4.